Hello everyone, today we're going to walk through the Pymaceuticals exercise. It's a good idea to have an idea of what we're trying to build by the end of the project and the data we're building it with. So first let's take a look at the finished product for the Pymaceuticals exercise. You'll see we're going to build a handful of plots, a few scatters, and also a bar graph that are based on two separate data files that will give us the reaction of mice to treatment by several different medicine regimens. You see here we're going through the file. You'll see a few of those scatters, and then here at the end a tumor change over 45-day treatment percentage bar graph. Let's take a look at the two data files that we're going to be using. The first file here gives a view of the different mice, the time points, metastatic sites, and tumor volumes. It looks like we have almost 2,000 data points here, but we're also going to need to find out which drug each mouse was given, and that data will be included in the second file here titled mouse drug data. You see we have the mouse ID here in both different data sets, and the second data set here has the drug that each mouse was administered. So we've been given these CSVs with plenty of information. We have a bunch of different mice and a lot of time points, and as with many data projects, we're going to have to perform a good bit of cleanup to orient our data into the format we need to build our plots. So let's begin. As always, we'll import our dependencies. We'll need to use Matplotlib for plotting and Pandas and NumPy for a lot of our data manipulation. We'll direct some variables to the data files that we just took a look at, and then load those files into separate data frames. We have our data frames of each of the data files, but one thing we're going to want to do is combine the data frames into a single one on mouse ID. You can see here, we'll go back into the files. Each of these data files has a mouse ID column. So we have a clear path to merge these two data frames so that we can have a full view of the data in a single data structure, and we'll preview that data frame once we're done so we can make sure we're on the right track, which is always a good habit to get into, is to preview the data structures that we're creating. Now the last thing we will do here in this cell is display that table that we created for preview so we can see what we'll be working with. So we'll use the head function, the head method, just to see the first 5 rows here. And it looks like we're getting started. We have everything in the same data frame, so we can get started with the first plot here, the tumor response to treatment. We'll get started by finding the mean tumor response data grouped by drug and time point. To plot these values, we need to create averages for each drug across multiple time points. Each drug has been given to multiple mice, so we'll find the average of the tumor responses using a group by and a mean function as well. We'll group it by the drug and the time point, and then find the mean of the tumor volume. We have the values. Now let's convert those into a data frame. Now let's take a look at the data frame we created, make sure we're on the right track. We'll take a look at the full data frame first off. Looks like we have the right values, so we'll switch that to head so it doesn't take up too much room. Now if we take a look at the finished product one more time, we can see that there are some extra markings here on each of the first two plots. It's a little bit more pronounced on the second plot here. These are error bars, and we're going to find the values for the error bars using another function that we have not used before. The SEM, or standard error mean function, essentially gives us the variability that exists mouse to mouse. We're going to find the standard error in much the same way we found the mean in the step above. We'll call the SEM function on tumor volume from the drug and time point group by of the full data frame, and we'll store it in the tumor vols SEM variable here. Now let's convert that data into a data frame. And finally, we'll preview the data frame to make sure that we're on the right track. Looks good. So now we have all the values that we want, but the data structures we created need to be reformatted for easier plotting. It can be hard to know which method to use here. In many areas, Pandas requires a lot of Google searching and experimentation. With practice, you'll start to build an approach for solving problems like this one that we really haven't come across yet before in class. A method that we're going to use is the pivot method that will allow us to move the vertical drug column horizontally so that the data is easier to read for us and for plotting. So the first thing we'll do is reset the index here, and then we can create a pivoted table using the pivot method, and we'll set it equal to tumor vols pivot mean. That's going to be one of our important variables for the rest of the plotting here. Make the index time point. The columns will be drugs. And again, that will be on the tumor volume values. We're going to do the same thing for the standard error mean data for the tumor volume. Lastly, we'll continue our good bit of practice in previewing the data so we know we have what we want. Usually we'll use the head method. I'll start out with it here because a lot of the data sets we work with are quite large, and it's nice to see just the first 5 rows that the head method gives us. But I want to view the whole data frame in this case just to get a better understanding of what the pivot method is doing for us. So we'll take away the head, and we see that we now have values for each drug at each time point that can be easily plotted. And we'll do that for the mean, and we have it for the standard error mean as well of tumor volume. So we have our data cleaned. Now let's plot the first chart, tumor response to treatment. Because we're plotting error bars, we're going to use the plt.errorbar syntax, where we can specify the error for each plot point. We'll use the index of the mean data frame, which is the different time point values as our x values, and specify each drug for our y values. We'll set the error equal to the tumor vols pivot SEM data frame and the specific drug that we're looking at. And then we can specify a marker style and color for each drug. We'll set the cap size to 3 for the error bars so we can more easily see it. Sometimes if the cap size is a little bit smaller, it's difficult to see. And we can copy and paste the formatting for a couple of the other drugs that we'll be looking at. It's just easier. You'll find that a lot of times you'll be able to copy and paste code that you already wrote if it would work for another situation. So we'll just make sure to make the correct tweaks in here. We'll make sure we're looking at all the different drugs that we need to be. And then we'll change the marker styles and colors for each drug. We can set the y limit and the x limit for our chart here. We'll set the y limit between 20 and 80 and the x limit between 0 and 45 for the different days that are in the time point index. And then we'll just do some titling and labeling for our chart. And we'll put in the legend as well. We can't forget to save the figure. I'm going to save it right in the same file path that we're currently in, but feel free to change that to a folder of output if you'd like. And then lastly, we can show our final product. Now we have a nice chart that plots the tumor response to treatment over 45 days for 3 drugs and the placebo. Let's move on to the metastatic response to treatment. We're going to approach this section in much the same way we approached the last section. So we're going to use the same group by methods, the mean, and then we'll find the standard error as well. So I'm going to make our data frame by finding the mean of metastatic sites grouped by drug and time point. Only this time we'll specify that we're looking for the mean of metastatic sites. we'll store that in a data frame. And then we'll preview the data frame. Looks like we're on the right track here. We'll do the same thing for the standard error because we'll need to plot that for this plot as well. Accordingly, we'll again use group by on the original data frame, but this time we'll use the SEM function on metastatic sites. And we'll preview the data frame again. Oh, looks like we have a little error here. Name clinical data complete. Oh, looks like we have a stray capitalization, so we'll fix that up, and looks like we have the data we're looking for. So again, we have the data we want now, but let's work on reformatting again so we can more easily plot everything. So once again, we'll start out by resetting the index, because the data frames we're using actually have multiple indexes. You'll see the drug and time point. Following that, we'll again use the pivot method to create columns for each drug by setting the drug across the top horizontally. And we will repeat the process for the standard error mean data that we created for the metastatic sites. Let's preview the data frames again so we can see how our reformatting came out. And once again, you'll see that we have clean data frames with values for each drug across the 45 days the drugs were administered to the mice. And we have them now for metastatic sites, for an average, and for the standard error mean. So now we can get started on plotting. So one thing that we can do is actually copy and paste some of the code that we already used and just make a few specific changes to fix it up. This will be one of the most useful skills you can really become adept at. Knowing when you have already written code that might work for another project or within the same project, and using it again with a few tweaks. So here we'll just need to adjust some of the data frame names that we're calling. We're calling the same drug, so we don't have to change those. For the standard error mean, we will need to adjust that slightly, just so it directs to the metastatic sites standard error mean that we calculated. The markers and the colors looks to be fine. It's always good to review and make sure that there aren't any other errors we're missing here. The Y limit probably needs to be adjusted as well. Right now we have it set 20 to 80. So let's take a look at the values we're plotting. And it looks like the highest number we'll see here is a little above 3.36. So Y limit of 0 to 4 should work quite well. So we were able to use much of the same plotting code for the second chart and reduce the time considerably that we took to finish it. You'll see that we just need to change some of the X and Y and error values, the Y limit, and some of the titling and labeling, but otherwise, we have the same skeleton for each of those plots, so it just makes sense to kind of copy and paste it and just tweak what we need to. Make sure you save it as a different file name, and then we can show what we came up with. Looks like we have a nice clean plot of the metastatic spread during treatment. Now let's move on to the survival rates section of the exercise, which will be slightly different from the first two plots. The first thing we want to do here is store the count of mice by the same group by that we've been using, drug and time point. And I'll use count on the tumor volume, although realistically we can really use count on any of the categories, because what we're really doing is counting how many data points still exist throughout the trial. So that will really count how many mice are still alive throughout the trial at each time point. We'll convert that data into a data frame, just as we have been doing, so we can plot it. And finally, we'll preview the data frame to make sure that it is what we are looking for, and it looks good. Let's try and reformat this just as we have been doing, so we can put it in a little bit better format for us to plot with. So we'll do the same method we've been using. We'll first reset the index for the data frame, and then we will use the pivot method to put the drug index horizontally across the data frame. Now let's preview the full data frame here. And it looks good. Looks like we can see how many surviving mice there were at each time point for each drug, and that should be pretty easy to plot now. We don't need to calculate standard error for this plot, so we have all the data we need to start charting. Because we don't have standard error, we can use the plt.plot method to create our chart this time around, but we can't forget that we are plotting percentage of surviving mice, so we'll include that calculation within the plot. We can copy and paste the first plot line for the other drugs and tweak a few areas. Next, we can set the limits for our plot, the titles, labels, the legend. Make sure to save the figure, and then finally we'll be able to show our work again. All right, fantastic. Now we're in a nice groove of creating data frames and plotting from them, but we are going to be doing something slightly different for the final plot. The summary bar graph is going to require us to calculate the percentage change of tumor volume for each drug during the 45-day time period. To do that, we're going to call on the tumor volume mean data frame that we created earlier in the exercise, and we will call the last value for each drug using .iloc -1 and the first value using .iloc 0. Together, we'll be able to use those to find the percentage change tumor volume for the 45-day period for each drug. Now we'll display the data and it looks good, but one thing to note is to make sure that your parentheses are in the right place. We have them in the right place now, but you'll see if we just move it slightly over to the end, you'll get some pretty wacky values. So it's important to make sure that your syntax is correct, not only for calculating means and averages and anything of that sort, but for anything really in pandas, it could be as simple as just moving a parentheses over. Now we have the percentage changes that we're looking for, but we really only need to plot 4 of them. So let's strip those out and create a tuple with them. Now we'll start plotting using slightly different syntax than before, both because we're plotting a bar graph, but also we're going to use some conditional functions to label each value on the graph. So before we get into that, let's take a look back at the plot we're trying to build, and you'll see coming up here green for negative values on the plot and red for positive values right here in the tumor change graph here. So that's what we're trying to build. This is another case of Googling being really necessary to pandas, learning pandas, and executing on pandas as we go forward, because we need to figure out a way to correctly label each of these values, and it's not really built into Matplotlib. We're going to be using the auto label function that requires us to pass values into it. So we're going to create a variable for passing percentage drugs and one for failing drugs, which their numbers are actually positive values because we want the tumors to shrink, not grow. So we'll specify 0 in the rex pass for capimulin, as it is the first member of each list we're using, and then the rex fail variable will house the other drugs, designated by 1:, which means from 1 onward, since those are the drugs that are positive values, hence they are growing tumors. Next, let's add some width values, labels, limits, and tick marks. Next, we need to create the functions that I mentioned before to label the bars for us. Now don't worry if you don't completely understand how these functions work. This is something that I Googled for, and I found a solution online that works for our purposes here. It's something that we're all going to need to do throughout our life as programmers. You often need to use Google. So the first time I write this function, it will be for the failing drugs, which are the final three: infubinol, ketopro, and placebo. And this function will essentially make sure that we're putting labels of the percentages for each bar in a visible location. And then we're going to need to create a second function that serves the same purpose but for capamulin. Now we can copy the first function and paste it right below, and the second function will be for the passing drugs. So we'll make that auto label pass. We'll change some of the values within here just to make sure that the label shows up exactly where we want to. You can go back and tweak this code if you want and kind of experiment with it and see where the labels will show up if you change some of the numbers. I suggest that. And now we have to call the functions that we just created for our variables, so the labels will show up in our plot. Next, we just have to save the figure, and we can finally show the last plot. And it looks good. Looks like we have the percentage changes for these 4 drugs, or the 3 drugs and the placebo. And they're all labeled correctly. Red for the tumor volumes that grew and green for the ones that shrunk. So that is Pymaceuticals. You could do a few things to spruce up these plots. If you want, you can import the Seaborn library to get some extra formatting and pretty colors. But getting this far has been a great achievement, so good job.